Welcome to the project demonstration of dual axis solar tracker. So by using PIC Microcontroller, the main application of this project is as we know that single axis solar tracker is only for tracking the solar panel when sun is moving from east to west. But during the winter the sun will be deviated towards the south, so that will be detected by this another two LDR sensors, and based on these two extra LDR sensors another motor will be controlled. So the below motor is a second there's a two axis solar tracking system, so that we can control the solar panel 360 degrees. So east to west and north deviation towards the south also will be controlled with the help of another DC motor. These two DC motors are using to main tracking for this one, and these limit switches are to limit the motion of this DC motor when it's moving east to west, and another limit switch got placed here. This is for north deviation limiting. Total 3 limit switches got placed here, and these two DC motors interface to the PIC microcontroller. We are using PIC 16F73 and interfacing to the controller through this L298 motor driver. So controller will take the input from these 4 LDRs. Based on the LDR input, so these 2 LDRs are used to control this DC motor input output, and these 2 LDRs are input, and based on that 2 LDRs the DC motor will be controlled the bottom side. So 4 LDRs are the input and 2 DC motors are the output in our project, along with the 3 limit switches are the input to the system. So we have interfaced the limit switches at pin number C5, C6, C7 and DC motors to the L298 motor driver at C0, C1, C2, C3 and A0, A1, A2, A3 for this LDR sections. So actually we are charging this battery directly with the help of this 12 volt 3 watt solar panel. As a low intensity, we can see the low LED intensity means low voltage generation. So whenever we want to charge a battery, if the absence of sunlight, connect this transformer by removing the solar panel from this T/S slot and on the power supply to the transformer. So it will get fully charged in a duration of 1 hour, at least 1 hour, maximum of 2 hours. Till the duration we should keep the battery under charging. So once time completion, you can disconnect this, and while main project demonstration we need to connect the solar panel at this T/S slot, and there is an on off switch. So this is the main on off switch. Above is the on, below is the off. Now on the system, so when we on that, it will get initialized to 0 position, right? You can see that after 2 limit switches touches, then automatically it will stops moving. And coming to the sun movement, so we are using the 12 volt 3.5 rpm DC motors in the both sections. You can see that sun deviation, right? So if I stop movement this mobile phone, then automatically the below motor also will be stops as the 2 LDRs getting the same lighting, right? You can see that when I'm moving again, it will move. Same for the east to west movement also, but it is controlled slowly. And once the movement touches this west side limit switches, that is indication of sunset done. Then it will come back to the east position to make the solar panel in east position, waiting for the sun in the east side. Right, when it touches, then automatically it will back to the east side. Again it will get initialized here, right? So you can hear the limit switch touches, then the motion will be stops. Again it will wait for the east, means the sunrise again, right? Okay, so this is a continuous process daily. Thank you.